Hey, welcome. Today we're going to talk about the stuff that makes up, well, literally everything. I'm talking about matter. It's the one thing that connects the stars, the air, and the device you're watching this on right now. Let's dive in. So here's our game plan. We're going to start big, asking what matter even is. Then we'll zoom way in to meet its tiniest building blocks, see how they get together and party, and then zoom back out to see how we can actually measure all this stuff in the real world. No, really, think about it for a second. The chair you're sitting on, the drink on your table, the very air in your lungs. What's the common thread? What makes them all real? The answer is so simple, and yet it's mind-blowingly cool. Okay, first things first. Let's get a handle on what we're even talking about. What is all this stuff that makes up our universe? It all boils down to this. If it takes up space, has volume, and it has some heft to it, meaning it has mass, then congratulations, it's matter. But here's the wild part. Its particles are always moving. Even in a solid brick that looks perfectly still, its insides are buzzing with energy. And you've seen matter in all its different moods, right? We call them states. You've got solids, liquids, and gases. Think ice, water, and steam. It's all the same stuff, H2O. Just with its particles vibrating at different speeds. And it doesn't even stop there. You get crazy stuff like plasma. That's what lightning and the sun are made of. So we've got a grip on what matter is, but what's it made of? To answer that, we have to shrink ourselves down way down, smaller than you can possibly imagine. And here it is, the atom. This is the ultimate Lego brick of the universe. Every single thing you can see, touch, or feel is built from these tiny structures. You can see it's got that dense little ball in the middle. That's the nucleus, and then a cloud of stuff zipping around it. And the recipe for the whole universe is surprisingly simple. In that center nucleus, you've got your positive protons and your neutral neutrons just hanging out. Then, orbiting on the outside are these teeny tiny negative electrons. Protons, neutrons, electrons. That's it. That's the whole toolkit for building everything. All right, pop quiz time. Based on what we just saw, if you count up all the protons in that nucleus and you add all the neutrons, what does that number give you? You got it. It's the atomic mass. That's basically how we weigh an atom. And it makes sense that it's all in the nucleus because those little electrons are so incredibly light, they barely even register on the scale. Okay, so we have our building blocks, the atoms. But here's the thing, atoms are super social. They almost never fly solo. They love to team up. And how they do that creates all the amazing variety of things we see around us. The simplest team-up is an element. Just think of it like a giant bin of only red Legos. A pure gold bar, it's made of nothing but gold atoms. A tank of pure oxygen, nothing but oxygen atoms. It's the most basic, pure substance you can get. Now, this is where some folks get a little tripped up, but it's pretty simple. When any two or more atoms link up, you get a molecule. But, and here's the important part, if those atoms come from different elements, then you've got a compound. So just remember, every compound is a type of molecule, but not every molecule is a compound. And this right here is a perfect example. Look on the left. You've got graphite, like in your pencil, and a diamond. They couldn't look more different, right? But believe it or not, they're both 100% pure carbon atoms, just arranged differently. Now on the right, you have compounds like water and salt, which are made by combining totally different kinds of atoms. Okay, one more quick check to make sure we're all on the same page. Think about water, H2O. Based on what we just said, would you call that a compound? Yes, you nailed it. It's absolutely a compound. Why? Because it's made of two different elements, hydrogen and oxygen stuck together. That's the definition right there. Awesome. So, we've gone from the biggest idea of matter all the way down to the tiniest atoms. Let's zoom back out and get practical. How do we actually measure all this stuff in the real world? First up, we've got mass. Mass is just a fancy word for how much stuff is packed into an object. And don't get this mixed up with weight. Your weight would change if you went to the moon, but your mass, the amount of you, stays exactly the same. We usually measure it in grams. Next, we have volume. This is just about how much space something takes up. If you have a perfect box, it's easy. Length times width times height. For a liquid, you can just pour it into a measuring cup. And here's a super handy trick. 1 cubic centimeter is the exact same amount of space as 1 milliliter. They're interchangeable. But what about something with a weird shape, like a key or a rock? How do you measure its volume? Well, you use this totally clever trick called displacement. You just take a known amount of water, plop your object in, and see how much the water level rises. That amount it rose, that is the volume of your object. So simple, so smart. All right, now for the grand finale. We're going to look at the one concept that ties mass and volume together in a beautiful way. This is where it all comes together. Let's talk about density.
So what is density? It's really just the answer to the question how much stuff is crammed into a certain amount of space. It's the relationship between an object's mass and its volume.
I mean, this picture says it all, doesn't it? You've got two boxes that are the exact same size, they have the same volume, but the box on the right clearly has way more stuff packed into it, so it has more mass. More mass in the same amount of space means it is more dense. It's really that straightforward. And once you get density, you start seeing it absolutely everywhere. It's why a giant steel cruise ship can float on water. It's why a hot air balloon rises into the sky. It's even why oil and vinegar separate in salad dressing. So now, it's your turn. Take a look around. What else in your world can be explained by this awesome, powerful idea? Thanks for digging into this with me.